Hello everyone! Today in this tutorial we will teach you how to work with aromatic compounds. We have two main objectives for this practice. The number one is that you will learn what the UPAC is and dose. The number two is that you will understand what is a hydrocarbon and how it is composed and how it is classified. And finally, the objective number three, and the most important for this tutorial, is that you will understand what is an aromatic and how to name it and draw structural formulas for it. We hope you enjoy it.
The UPAC nomenclature of organic chemistry is a systematic method of naming organic chemical compounds as recommended by the International Union of Pure and Applied Chemistry, the UPAC. Ideally, every possible organic compound should have a name from which an explicit structural formula can be created.
So, what are hydrocarbons and what are they composed of? Well, hydrocarbons are the simplest organic compound, and these are composed of hydrogen and carbon atoms. That's it. So, they are found in the air by the decomposition of organic matter. An example of hydrocarbons in the daily life can be gasoline, which is used as fuel for the cars.
Alkanes. Well, alkanes are saturated hydrocarbons that are composed of only single covalent bonds. They are also called paraffins. Here I'm gonna tell you some properties of the alkanes. Well, in chemical, they have only one property, which is that they have low reactivity. In physical, we have that their melting and boiling point increases with the increasing of the carbon atoms. And then we have that they are not non-polar, so this means that they are immiscible, which is that they cannot be soluble in water. Also, we have that the density increases with the increasing of the carbon atoms.
The hydrocarbons are organic compounds that are made of only hydrogen and carbon atoms. They are found in many places, including crude oil and natural gas. The hydrocarbons are divided in three main groups according to the type of bonds they contain, which are alkanes, alkenes, and alkynes. The alkanes are hydrocarbons which contain one single bond. They are called saturated hydrocarbons because there is an hydrogen in every possible location. The alkenes are almost completely insoluble in water, and they are normally soft with low melting points. The alkenes contain carbon-carbon double bond. This carbon-carbon double bond changes the physical properties of alkenes. At room temperature, they exist in three phases, which are solid, liquids, and gases. The alkenes are third homogeneous series of organic compounds of hydrogen and carbon, where there is at least one triple bond between these atoms in the molecules. The alkenes are said to be unsaturated because of the existence of a multiple bond in the molecule. The properties of alkynes are very similar to the alkenes. The alkenes are generally non-polar molecules with a little insolubility in polar solvents, such as water. And they have solubility in non-polar solvents such as ether and acetone. The aromatic compounds are cyclic compounds in which all ring atoms participate in a network of p bonds, resulting in unusual stability. The aromatic compounds are less reactive than alkenes, making them useful in industrial solvents of nonpolar compounds. The aromatic compounds are produced from petroleum and coal tea.
Steps for naming aromatic compound. The first one is to write the name of the aromatic compound. The second one is to number the aromatic ring starting from the substituent. And the third one is to give the location and name of each substituent as a prefix to the name. Here is the example number 1. Here you can see a benzene ring and 2 chlorus. Okay, now we already named them. So the second step is to number them. We need to stay alert that we have to number it, from the shortest that we can do. It means that if here I have 1 chloro, I don't have to put like this one is the number 1, 2, 3, 4, 5, and 6, because this is like much more numbers, as if we can make them if this chloro was the number 1 and this one is the number 2. So we are going to write in the formula we can write 1, 2, and we are going to add the prefix D because of the 2 chlorus and benzene. And here is the answer.
Here's an easy example into naming aromatic compounds. Here we have our benzene ring, and we have OH and chlorine. Since OH is our highest priority, we're gonna put a number 1 and count clockwise. Since the OH in a benzene is called phenol, that is gonna be our parent name. And the prefix of chlorine in a carbon 3 is called 3-chloro. And when we put this together, our name will be 3-chlorophenol. And there you go.
Okay, this is an example of how to name the compounds. We have this one. Only the figure is called benzene, but we have these two. According to the rules, the first thing that we have to do, the first thing, is to numbers to the side that we think that it is better. I'm going to number to this, from this to this. Okay, we have it like this, and now we going to give the name to the figure. The name will be 1,3 dichloro, because we have 2 chloros benzene, that it is equal to have 2 chloros plus 1 benzene.
Hi guys, my name is Adrian, and I'm going to talk to you about how to identify the structure of a hydrocarbon form by its UPAC name, in this case of aromatics. Hydrocarbons are frequently have both historical and UPAC names. The UPAC names can be used to draw chemical structures. To draw a hydrocarbon structure, start with a carbon backbone, which can include a ring structure like this. We have the name of P-silyl, that it's named 1,4-dimethyl benzene. So with this name we can know what is going to go where. After the carbon backbone is drawn, add the substituent groups and the double and triple bonds that are indicated in the prefixes and suffixes in the chemical name here. So, by the name, we know that here goes CH3 and here another CH3.
Okay, so let's suppose that we have this, or example number 1, and it says 1,2 dichlorobenzene, and we want to draw its structural formula. So first we're going to analyze this. We can see dichloro. This tells us that there are 2 chlorine atoms, which means let's write it, 2 chlorine atoms, which is this. And this is telling us where they are placed. It's telling us they're placed in the first and second position. Okay, so only with that information we are able to draw our structural formula, in this case obviously. So it doesn't matter where we start, or number 1 or number 2. So we're just going to write our atoms. So we write structure, and this is our 1,2.
Okay, this is an example of how to draw the structural formula. The first thing that we have is the name, that is ethyl benzene. The first thing that we are going to do is to draw the benzene. So we have it like this. These two shapes are correct, it's the same. Okay, now that we have the benzene, we are going to draw the ethyl. So we have it right here. This. So now we have the structural formula and the name.
Okay, so we have 3 chlorophenol. The phenol tells us that in the benzene ring it's gonna be the OH on top, and the chloro and the 3 means that the chloro is in a 3 position. So we're gonna count clockwise, 1, 2, 3. In the third one we're gonna put the chlorine, and there you go. Here's the structural formula for the aromatic compound.
Main structure of aromatic groups. In here is shown that main structure of aromatic groups. In these 2 examples, as you can see, aromatic structures are different from alkene or alkenes or any other alkenes. A molecular orbital description of benzene provides more satisfying and more general treatment for aromaticity. We know that benzene has a planar hexagonal structure in which all the carbon atoms are sp2. Wrote it like this, sp2. That these sp2s are hybridized, strange word, and all the carbon bonds are equal in length, as you can see in the examples.
As a conclusion, the hydrocarbons are the primary source of energy in our current civilizations because they are useful in the realization and fabrication of many products such as plastics and different kinds of materials. It also relates to hydrocarbons are divided into 3 main groups, which are alkenes, alkynes, and alkanes, each one depending on their number of bonds. I also learned how to name the aromatic compounds and how to write them in structural formula.
As my conclusion, I think that the aromatic hydrocarbon compounds are very important because everything that comes from nature, or almost everything, it is made of hydrocarbons, including us. The aromatic compound is a way to express more easily a compound, so for me that is very important.
My personal reflection from this stage is that at the beginning of the stage I thought that this was like a difficult topic because I never saw this on my high school, but during the classes that we had, I realized that this topic is easier than I thought, and also it is like fun, really, like making all the formulas and watching what we have to do with all the things that we had. and I have fun like making this video, and I like this stage very much.
So we made this activity as a team, and I really enjoyed making it, and I hope you enjoyed it too. Thank you for watching.